What exactly are we missing by focusing on such a short span of time?
I think we're missing most of what we are. So one of the issues I've been thinking about this like really viscerally lately. It's weird when you do theoretical physics because I think it like literally changes the structure of your brain
Hmm.
and you see the world differently, especially when you're trying to build new abstractions.
Do you think it's possible if you're a theoretical physicist, that, like, it's easy to fall off the cliff and go descend into madness?
I mean, I think you're always on the edge of it, but I think what is amazing about being a scientist and trying to do things rigorously is it keeps your sanity. So I think if I wasn't a theoretical physicist, I would be probably not sane.
Wow.
But what it forces you to do is hold the fire. Like you have to hold yourself to the fire of like these abstractions in my mind have to really correspond to reality, and I have to really test that all the time. And so I love building new abstractions and I love going to those like incredibly creative uh spaces that people don't see as part of the way that we understand the world now. But ultimately, I have to make sure that whatever I'm pulling from that space is something that's really usable and really like relates to the world outside of me. That's what science is.
So we were talking about what we're missing when we look at a small stretch of time and a small stretch of space.
Yeah. So the issue is we evolve perception to see reality a certain way, right? So for us, space is really important and time feels fleeting. And I had a really wonderful mentor, Paul Davies, most of my career. And Paul's amazing because he gives these like little seed thought experiments all the time. Like, something he used to ask me all the time was when I was a postdoc. This is kind of a random tangent, but was like, how much of the universe could be converted into technology? If you were thinking about like, long-term futures and stuff like that. And it's like a weird thought experiment, but like there's a lot of deep things there. I do think a lot about the fact that we're really limited in our interactions with reality by the particular architectures that we evolved. And so we're not seeing everything. And in fact, our technology tells us this all the time because it allows us to see the world in new ways by basically allowing us to perceive the world in ways that we couldn't otherwise. And so what I'm getting at with this is I think that living objects are actually huge. Like they're some of the biggest structures in the universe, but they are not big in space, they are big in time. And we actually can't resolve that feature. We don't interact with it on a regular basis. So we see them as these fleeting things that have this really short temporal clock time without seeing how large they are. When I'm saying time here, I really like the way that people could picture it is in terms of causal structure. So if you think about the history of the universe to get to you, and you imagine that that entire history is you, that is the picture I have in my mind when I look at every living thing.
So you have a tweet for everything. You tweeted.
Doesn't everyone?
You have a lot of poetic, profound tweets. Sometimes
Thank you.
they're puzzles that take a long time to figure out.
Well, you know what it is? The trick is the reason they're hard to write is because it's compressing a very deep idea into a short amount of space. And I really like doing that intellectual exercise because I find it productive for me.
Yeah, it's a very interesting kind of compression algorithm, though.
Yeah,
And
I like language. I think it's really fun to play with.
yeah, I wonder if AI can decompress it. That'd be
I
interesting.
think
It's an interesting
I
challenge.
would like to try this, but I think I use language in certain ways that are non-canonical, and I do it very purposefully. And it would be interesting to me how a AI would interpret it.
Yeah, your tweets would be a good Turing test
There you
for
go.
this for super intelligence. Anyway, you tweeted that things only look emergent because we can't see time.
hmm
So, if we could see time, what would the world look like? You're saying you'll be able to see everything that an object has been, every step of the way that led to this current moment, and all the interactions that required to make that evolution happen. So you would see this gigantic tail.
The universe is far larger in time than it is in space.
Yeah.
And this planet is one of the biggest things in the universe.
Also, the more complexity, the bigger
Yeah.
body
So
of the
like
object it's on.
technosphere. I think the modern technosphere is the largest object in time in the universe that we know about.
And when you say technosphere, what do you mean?
I mean the global integration of life and technology on this planet.
So all the things, all the technological things we've created?
Mhm. But
So,
I don't think of them as separate. They're like very integrated with the structure that generated them. So you can almost imagine it like time is constantly bifurcating and it's generating new structures. And these new structures are, um, you know, locally constructing the future. And so things like you and I are very close together in time because we didn't diverge like very early in the history of the universe. It's very recent. And I think this is one of the reasons that we can understand each other so well and we can communicate effectively. And I might have some sense of what it feels like to be you. But, other organisms bifurcated from us in time earlier. This is just the concept of phylogeny, right? But if you take that deeper and you really think about that as the structure of the physics that generates life, and you take that very seriously, all of that causation is still bundled up in the objects we observe today. And um, so you and I are close in this temporal structure, but we're also and we're so close because we're really big, and we only are very different in sort of like the most recent moments in the time that's like embedded in us.
uh,
It's hard to use words to visualize what's in minds. I have such a hard time with this sometimes. I actually I was thinking on the way over here. I was like, you have pictures in your brain and then they're hard to put into words. But I realized I always say I have a visual, but it's not actually I have a visual, it's I have a feeling. Because oftentimes I cannot actually draw a picture in my mind for the things that I say. But sometimes they go through a picture before they get to words. But I like experimenting with words because I think they help paint pictures.
yeah, it's again some kind of compressed feeling that you can query to get a sense of the bigger visualization that you have in mind.
Yeah.
It's just a really nice compression. But I think the idea of this object that in it contains all the information about the history of an
Hmm.
entity that you see now, just trying to visualize that is pretty cool.
Yeah.
I mean, obviously the mind breaks down quickly as you step seconds and minutes back in
Yeah.
time. But
For sure.
I guess it's just a gigantic object
Yeah.
we're supposed to be thinking about.
Yeah, I think so. And I think this is one of the reasons that we have such an ability to abstract as humans because we are so gigantic that like the space that we can go back into is really large. So like the more abstract you're going, like the deeper you're going in that space.
But in that sense, aren't we fundamentally all connected?
Yes. And this is why the definition of life cannot be the individual. It has to be these lineages because they're all connected, they're interwoven, and they're exchanging parts all the time.
Yeah, so that maybe there's certain aspects of those lineages that can be lifelike. They can be characteristics that can be measured, like with assembly theory, that have
Yeah,
more or less life, but they're
that's
all
right.
just fingertips of a
Yeah.
much bigger object.
Yeah, I think life is very high dimensional. And in fact, I think you can be alive in some dimensions and not in others. Like if you could project all the causation that's in you in some features of you, very little causation is required and like very little history. And in some features a lot is. So it's quite difficult to take this really high dimensional, very deep structure and project it into things that we really can understand and say like this is the one thing um, that we're seeing because it's not one thing.
It's funny we're talking about this now, and I'm slowly starting to realize one of the things I saw when I took ayahuasca afterwards, actually. So the actual ceremony is 4 or 5 hours, but afterwards you're still riding whatever the thing that you're riding. And I got a chance to afterwards hang out with some friends and just shoot the shit in the forest, and I get to see their faces. And what was happening with their faces and their hair is I would get this interesting effect. First of all, everything was beautiful, and I just had so much love for everybody, but I could see their past selves like behind them. It was this effect where I guess it's a blurring effect of where, like, if I move like this, the faces that were
Oh,
just
that's
there
so
are still
cool.
there, and it would
Yeah.
just float like this, these behind them, which will create this incredible effect. But it's also another way to think about that is I'm visualizing a little bit of that object of the thing they wore just a few seconds ago. It's a
Yeah,
cool little effect.
that's very cool.
And now it's like giving it a bit more profundity to the effect that was just beautiful aesthetically, but it's also beautiful from a physics perspective because
Mhm.
that is a past self. I get a little glimpse at the past selves that they were, but then you take that to its natural conclusion, not just a few seconds ago, but just to the beginning of the universe, and you can
Yeah,
probably get
billions
to
of
that,
years, yeah.
get down that lineage.
It's crazy that there's billions of years inside all of us.
All of us,
Yeah.
and then we connect. Obviously,
Yeah.
not too long ago.
Yeah.
Uh, you mentioned just the technosphere, and you also wrote that the most alive thing on this planet is our technosphere.
Yeah.
Why is the technology we create a kind of life form? Why are you seeing it as life?
Because it's creative, but with us, obviously, like not independently of us. And also because of this sort of lineage view of life. And I think about life often as a planetary scale phenomena, because that's sort of the natural boundary for all of this causation that's bundled in every object in our biosphere. And so for me, it's just sort of the current boundary of how far life on our planet has pushed into the things that our universe can generate. And so it's the furthest thing, it's the biggest thing. And I think a lot about the nature of life across different scales. And so, we have cells inside of us that are alive and we feel like we're alive, but we don't often think about the societies that we're embedded in as alive or a global scale organization of us and our technology on the planet as alive. But I think if you have this uh, deeper view into the nature of life, which I think is necessary also to solve the origin of life, then you have to include those things.
All of them. So you have to simultaneously think about
Every
life
scale.
at every single scale, the
Yeah.
planetary and the bacteria level.
Yeah. This is the hard thing about solving the problem of life, I think, is how many things you have to integrate into building a sort of a unified picture of this thing that we want to call life. And a lot of our theories of physics are built on um, building deep regularities that explain a really broad class of phenomena. And I think we haven't really traditionally thought about life that way. But I think to get at some of these hardest questions, like looking for life on other planets or the origin of life, you really have to think about it that way.
Mhm.
And so most of like my professional work is just trying to understand like every single thing on this planet that might be an example of life, which is pretty much everything, and then trying to figure out like what's the deeper structure underlying that.
Yeah, Schrodinger wrote that living matter, while not eluding the laws of physics as established up to date, is likely to involve other laws of physics hitherto unknown. So to him,
I love that quote.
there was a sense that at the bottom of this are new laws of physics that could explain this
Yeah.
thing that we call life.
Yeah. Schrodinger really tried to do what physicists try to do, which is explain things. And his attempt was to try to explain life in terms of non-equilibrium physics because he thought that was the best description that we could generate at the time. And so he did come up with something really insightful, which was to predict the structure of DNA as an aperiodic crystal. And that was for a very precise reason that, that was the only kind of physical structure that could encode enough information to actually specify a cell. We knew some things about genes, but not about DNA and its actual structure when he proposed that. But in the book, he tried to explain life as kind of going against entropy. And so some people have talked about it as like Schrodinger's paradox. How can life persist when the second law of thermodynamics is there? But in open systems, that's not so problematic. And really, the question is, why can life generate so much order? And we don't have a physics to describe that. And it's interesting, generations of physicists have thought about this problem. Oftentimes, it's like when people are retiring, they're like, oh, now I can work on life.
Mhm.
Or they're like more senior in their career and they worked on other more traditional problems. And there's still a lot of impetus in the physics community to think that non equilibrium physics will explain life. But I think that's not the right approach. I don't think ultimately the solution to what life is there. And I don't really think entropy has much to do with it unless it's entirely reformulated.
Well, because you have to explain how interesting order, how complexity emerges from the soup,
Yes, from randomness.
from randomness. Physics currently can't do that.
No. Physics hardly even acknowledges that the universe is random at its base. We like to think we live in a deterministic universe and everything's deterministic, but I think that's probably an artifact of the way that we've written down laws of physics since Newton invented modern physics in his conception of motion and gravity, which, he formulated laws that had initial conditions and fixed dynamical laws. And that's been sort of become the standard canon of how people think the universe works and how we need to describe any physical system is with an initial condition and a law of motion. And I think that's not actually the way the universe really works. I think it's a good approximation for the kind of systems that physicists have studied so far. And I think it will radically fail in the long term at describing reality at its more basal levels. I'm not saying there's a base. I don't think that reality has a ground. And I don't think there's a theory of everything. But I think there are better theories, and I think there are more explanatory theories, and I think we can get to something that explains much more than the current laws of physics do.
When you say theory of everything, you mean like everything, everything.
Yeah, like in physics right now, it's really popular to talk about theories of everything. So string theory is supposed to be a theory of everything because it unifies quantum mechanics and gravity. And people have their different pet theories of everything. And the challenge with a theory of everything, I really love this quote from David Krakauer, which is a theory of everything is a theory of everything except those things that theorize.
Oh, you mean removing the observer from the thing?
Yeah, but it's also weird because if a theory of everything explained everything, it should also explain the theory. So the theory has to be recursive. And none of our theories of physics are recursive. So it's just it's a weird concept.
Yeah, but it's very difficult to integrate the observer into a theory.
I don't think so. I think you can build a theory acknowledging that you're an observer inside the universe.
But doesn't it become recursive in that way? And that's you're saying it's possible to make a theory that's okay with that?
I think so. I mean, I don't think there's always going to be the paradox of another meta level you could build on the meta level, right? So like if you assume this is your universe and you're the observer outside of it, you have some meta description of that universe, but then you need a meta description of you describing that universe, right? So, this is one of the biggest challenges that we face being observers inside our universe, and also, why the paradoxes and the foundations of mathematics and any place that we try to have observers in the system or a system describing itself show up. But I think it is possible to build a physics that builds in those things intrinsically without having them be paradoxical or have holes in the descriptions. And so one place I think about this quite a lot, which I think can give you sort of a more concrete example, is the nature of like what we call fundamental. So we typically define fundamental right now in terms of the smallest indivisible units of matter. So again, you have to have a definition of what you think material is and matter is. But right now, what's fundamental are elementary particles. And we think they're fundamental because we can't break them apart further. And obviously, we have theories like string theory that, if they're right, would replace the current description of what's the most fundamental thing in our universe by replacing it with something smaller. But we can't get to those theories because we're technologically limited. And so if you look at this from a historical perspective and you think about explanations changing as physical systems like us learn more about the reality in which they live. We once considered atoms to be the most fundamental thing. And, it literally comes from the word indivisible. And then we realized atoms had substructure because we built better technology, which allowed us to quote unquote see the world better and resolve smaller features of it. And then we built even better technology, which allowed us to see even smaller structure and get down to the standard model particles. And we think that might be structure below that, but we can't get there yet with our technology. So what's fundamental, the way we talk about it in current physics, is not actually fundamental. It's the boundaries of what we can observe in our universe, what we can see with our technology. And so if you want to build a theory that's about us and about what's inside the universe that we can observe, not what's at the boundary of it, you need to talk about objects that are in the universe that you can actually break apart to smaller things. So I think the things that are fundamental are actually the constructed objects. They're the ones that really exist and you really understand their properties because you know how the universe constructed them, because you can actually take them apart. You can understand the intrinsic laws that built them. But the things at the boundary are just at the boundary. They're evolving with us, and we'll learn more about that structure as we go along. But really, if we want to talk about what's fundamental inside our universe, we have to talk about all these things that are traditionally considered emergent, but really just structures in time that have causal histories that constructed them and, are really actually what our universe is about.
So we should focus on the construction methodology as the fundamental thing. But do you think there's a bottom to the smallest possible thing that makes up the universe?
I don't see one.
And it'll take way too long. It'll take longer to find that than it will to understand the mechanism that created life.
I think so, yeah. I think for me, the frontier in modern physics, where the new physics lies, is not in high energy particle physics. It's not in quantum gravity. It's not in any of these sort of traditionally sold, this is going to be the newest, deepest insight we have into the nature of reality. It is going to be in studying the problems of life and intelligence and the things that are sort of also our current existential crises as a civilization or a culture that's going through an existential trauma of inventing technologies that we don't understand right now.
The existential trauma and the terror we feel that technology might somehow destroy us meaning intelligent living organisms,
Right.
yet we don't understand what that even means.
Well, humans have always been afraid of our technologies, though, right? So it's kind of a fascinating thing that every time we invent something we don't understand, it takes us a little while to catch up with it.
I think also in part humans kind of love being afraid.
Yeah, we love being traumatized.
It's weird.
We want to learn more, and then when we learn more, it traumatizes us. I never thought about it this before, but I think this is one of the reasons I love what I do is because it traumatizes me all the time. That sounds really bad. But what I mean is I love the shock of realizing that coming to understand something in a way that you never understood it before. I think it seems to me when I see a lot of the ways other people react to new ideas that they don't feel that way intrinsically. But for me, that's why I do what I do. I love that feeling.
But you're also working on a topic where it's fundamentally ego destroying because you're talking about life. It's humbling to think that we're not, the individual human is not special.
Yeah.
And you're very viscerally exploring that.
Yeah. I'm trying to embody that because I think you have to live the physics to understand it. But there's a great quote about Einstein. I don't know if this is true or not, that he once said that he could feel a light beam in his belly. And I think, yeah. But I think you got to think about it though, right? If you're a really deep thinker and you're really thinking about reality that deeply and you are part of the reality that you're trying to describe, you feel it. You really feel it.
That's what I was saying about you're always walking along the cliff. If you fall off, you're falling into madness.
Yes. It's a constant descent into madness.
The fascinating thing about physicists and madness is that you don't know if you've fallen off the cliff.
Yeah, you don't know.
That's the cool thing about
I rely
madness.
on other people to tell me. Actually, this is very funny because I have these conversations with my students often. They're worried about going crazy. And I have to reassure them that one of the reasons they'll stay sane is by trying to work on concrete problems.
Going crazy or waking up, I don't know which one it is.
Yeah.